let's look at two examples of direct linear variation. Example A, the stretch S of a spring varies directly as the mass M in kilograms of the load pulling it. A load of 13 kilograms causes the spring to stretch 18 centimeters. And just to give you an idea of what we're doing here, just imagine a spring, okay, just connected, say, to the ceiling or some high point, and on the end of that spring, okay, you have a mass attached, and the mass will then cause that spring to stretch downwards. So part I, find the variation equation relating S to M. So that's going to be in the form y equals kx. Okay, so part 2, so calculate the stretch caused by a mass of 22 kilograms. Part 3, determine the mass that will cause a stretch of 35 centimeters. And then part 4, state one limitation of this model. Okay. So I'm going to answer this on a different board, on a separate board, because obviously I've used up all the space on this one. Okay, so let's have a look at part I. Okay. It says find the variation equation relating S to M. And probably arguably is probably the most important part, because this is what we're going to use to answer the subsequent parts. Okay, so part I, this is going to be in the form S is equal to Km. Okay, and K is the constant of variation, or the constant of proportionality, which we need to find. So that's really the first step, or the first major step, apart from writing the equation, is to calculate the value of K, or to determine it from the data in the question. So going back to the second part of the question, it says a load of 13 kilograms causes the spring to stretch 18 centimeters. Okay. So what we'll do is that we'll substitute these two values into our variation equation and then solve for K. Okay. So 18 centimeters, okay, is equal to K times 13 kilograms. Divide both sides by 13, so moving the 13 over, okay, 18 on 13 equals K, therefore K is equal to 18 on 13, so just switching those around. So what would the equation be then? Okay, the variation equation. So therefore, S is equal to 18 on 13 multiplied by M. Okay. Next part, calculate the stretch caused by a mass of 22 kilograms. Okay. So M equals 22, and we're going to substitute that into our variation equation. Okay. So S is equal to 18 on 13 multiplied by 22. Okay. Okay, just enter that in. Hopefully you can see that. I'll just brighten that a little bit. 18 on 13 multiplied by 22, and we get 30.46. Okay, we'll enter the two decimal places. Okay. Then it says determine the mass that will cause a stretch of 35 centimeters. So the stretch is 35 centimeters. Substituting that into our variation equation, we have 35 centimeters is equal to 18 on 13 multiplied by M, and we need to solve now for M, okay, the mass that's going to cause that spring to stretch 35 centimeters. Okay, so what we'll do, we're going to divide both sides by 18 on 13, so 35 divided by 18 over 13 equals M, therefore M is equal to, okay, let's work that out now, 35 divided by 18 over 13, and we get 25.2777 or 25.28. 0.28 kilograms, and that's corrected to decimal places. And the last part 4, state one limitation of this model. Okay, and there's lots of answers for that one. So I guess if you imagine a spring, okay, does the spring have infinite stretch? Okay, there is a limitation to the spring, to the stretch of the spring. Okay. Cannot be overstretched, as it will not spring back into shape. Okay, once the mass is removed. Okay. There might be other answers as well, but that's probably one of the more obvious ones. Okay, let's have a look at another example. Okay. The weight of a person on Mars is proportional to their weight on Earth. A 75 kilogram person on Earth weighs 28.2 kilograms on Mars. So, part I. A person weighs 58 kilograms on Earth. How much would they weigh on Mars? And part 2, a person on Mars weighs 33 kilograms. How much would they weigh on Earth? Okay. So this one, it's not broken up or scaffolded as much as the previous example. Okay. But we do have some data that we can use, and we know that there's a direct linear variation occurring here. Okay. So I'm just going to answer on this board here. Okay. First of all, we need the variation equation. So let's say Mars is equal to K multiplied by the mass on Earth. So this is the mass on Mars, mass on Earth, and there's our constant of variation. So let's go back to the data in the question. What do we know? We know that a 75 kilogram person on Earth weighs 28.2 kilograms on Mars. Okay. So 28.2 is equal to K multiplied by 75. Now we need to solve for the constant of variation. Okay. So we're going to take the 75, the multiply by 75, we're going to move it over, turn it into a division. Okay. So K is equal to 28.2 divided by 75. Okay. So 28.2 divided by 75, and we get 0.376. Therefore, our variation equation is M, mass on Mars, is equal to 0.376 multiplied by mass on Earth. Okay. Now we can proceed to answer part I. So a person weighs 58 kilograms on Earth. How much would they weigh on Mars? Okay. So their mass on Earth is 58 kilograms. Substituting 58 in for E in our variation equation. So Mars is equal to 376 multiplied by the mass on Earth. Okay, so 0.376 multiplied by their mass on Earth, so 58 is equal to 21.808. Okay. What about part 2? A person on Mars weighs 33 kilograms. How much would they weigh on Earth? Okay. So part 2, their mass on Mars is 33 kilograms. Substituting that into our variation equation. So this is our variation equation there. Okay. 33 is equal to 0.376 multiplied by their mass on Earth. Rearranging this equation. Okay. So we're going to divide 33 by 0.376. Okay. Mass on Earth is equal to 33 divided by 0.376. Okay, 33 divided by 0.376. And we get 87.765 or 87.77. Correct to 2 decimal places. Okay, you'll be told what to round to in the question anyway, or generally you're normally told what the rounding is, but typically I'd usually round to 2 or 3 decimal places. It doesn't really matter. The important thing is that you know how to work with these direct linear variation questions. Okay, sometimes it could be given in the form of a graph or a table of values. Okay, so but it works basically the same way. Okay, we need to find the constant of variation. Okay, after we first of all write down the equation, or the variation equation first. Once we have the constant of variation, finding that, then we can proceed to answer these questions.